Hello everyone. So today we'll continue our lecture series which we started before. So we are discussing here different MCQs for SSC JEE. Okay. So we have started the thermodynamics subject here. So already we have discussed 20 questions before. So today we'll be trying to solve another 20 questions here. So let us start it. So I think we have completed up to 20 questions. So let us start from 21st question. Okay, so read the question carefully. So it is telling that specific enthalpy and velocity of steam at inlet and exit of steam turbine running at steady state are given below. Okay, so specific enthalpy, that is H, and velocity B is given at inlet, that is H1 and H2 are given, and velocity, that is V1 and V2 is given, and the rate of heat loss from the turbine per kg. So per kg of steam flow, so we can say M is also given, that is 1 kg per second. Okay, then next thing, that is per kg of steam flow at the rate 5 kilowatt. Okay, so heat loss, that is for 5 kilowatt, so Q is given 5 kilowatt. Okay, then neglecting changes in potential energy, so potential energy will be neglected here, and we need to calculate what the power developed in kilowatt. Okay, so we need to calculate power. So power means power in terms of work. Okay, so if we can find out power, then sorry, work, then if we will be dividing by 60, then we can calculate power. Okay, so let us try to solve this one. Okay, so as it is telling that is the steady state condition. Okay, so we know the steady flow energy equation, that is what, that is H1 plus V1 square by 2 plus Z1. Okay, it will be multiplied with mass flow rate m dot plus Q will be equal to what, m dot all into H1 plus B2 square by 2 plus Z2 plus W. Okay, so here potential energy is neglected, so Z2 Z1 term will be neglected, and here everything is given. So m dot is given, H1 is given, V1 is given, then here m dot sorry, H1 B2 square. Okay, so everything is given and we need to calculate W only, so Q is also given. So let us try to solve it. Okay, so what is that, what are these values? Okay, we need to calculate what, W. So W we can write H1 minus H2 plus V1 square minus V2 square divided by 2 plus Q. Okay, so H1 is here, that is 3250 minus H2 is here 2360 plus, okay, so it is in kilojoule per kg. Then in terms of velocity, so V1 is given 180, so square of 180 minus V2 is given 5, so square of 5 divided by 2, and if I want to convert into kilojoule per kg, because everything is in the kilojoule per kg, so I need to multiply 1000 here plus, and this is kilowatt, in terms of kilowatt it is given, so I can write what, that is 5. Okay, so each term is in the form of kilowatt, because one is multiplied here, another term 1 is multiplied here, so 1 kg per second. Okay, so kilojoule per kg into multiplied by kg per second, so we can get the value, that is kilowatt. Okay, so if we'll be calculating this, so 3250 minus 2360, so we can get 890 plus if we'll be squaring this one, then we'll be getting 32400. Then 5 square, that is 25. Then if we'll be deduct 25 from 32400, then we'll be getting a 32375 divided by 2000. So we can get that value 16.18. Okay, plus we can add here 5. So if we be calculating this value, then we'll be getting option 2, that is 911.18. So approximately we'll be getting 911.2. so this is the option. Okay, so moving next, the maximum theoretical work obtainable when the system interacts to equilibrium with reference to environment, it is called. Okay, so it is energy. The maximum theoretical work obtainable from a system when interacts with a reference to environment, so it is called as your energy. Okay, so an isolated system is one which okay, so in case of an isolated system, what happens, your energy, neither energy or nor your mass can be transferred from the system to surrounding. Okay, so there will be no interaction of energy or mass in a isolated system. Likewise, if we will be discussing about the open system, then there will be interaction in between your mass and mass and energy. And in case of your closed system, there will be only transfer or only interaction of energy, but there will be no interaction of mass. So we have to check the options here. So permit the passage of energy across the cylinder, across the boundary, no. So option 1 is correct. Permit passage of energy only, no. Okay, so it doesn't allow energy, so it doesn't permit the passage of energy and matters across. Okay, so it doesn't allow. C is the correct option here. So permit the passage of matter only, D is also wrong, so C is the correct answer here. Okay, so moving next, the measurement of thermodynamic property is known as temperature. Okay, is based on, okay, we know this is zeroth law of thermodynamics. So zeroth law is telling about the temperature only. Okay, so when in any question you will be getting about temperature, so it is telling by your zeroth law of thermodynamics. If then we can say what your first law of thermodynamics is telling about. So it is telling about the internal energy. So zeroth law is telling about the temperature, first law is telling about the internal energy. And what does your second law of thermodynamics say? So second law of thermodynamics is about your entropy. Okay, and third law of thermodynamics tell about your what, absolute zero temperature. Okay, then moving next, which thermometer is independent of substance or material in construction? Okay, so independent of substance or material basically is your ideal gas thermometer. So for 25 your option C will be correct, and for 24 option A is correct. Okay, so moving next, the perpetual motion machine of first kind, that is a machine which produces power without consuming any energy, is, okay, so basically perpetual machine of first kind is not possible, okay, according to what, first law of thermodynamics. Okay, what does your first law of thermodynamics tell about? So it is telling about your conservation of energy, means whatever energy will be getting, that amount of energy we should provide to the any system. Okay, so but perpetual motion of first kind, it is telling that without consuming any energy we will be getting some work, okay, some power. So that will be, that is impossible according to your first law of thermodynamics. So let us check which option is correct. So possible, possible according to first law of thermodynamics, no, that is wrong. Then impossible according to the first law of thermodynamics, so B is the option correct. Impossible according to second law of thermodynamics, possible according to second law of thermodynamics. So all the three options are wrong, but B, option B is the correct one. Then question number 27. So in Rankine cycle, regeneration results in higher efficiency because what? Okay, so what do you mean? What do you mean by regeneration actually? So let us draw the Rankine cycle. So if the temperature versus entropy diagram. So if this is the vapor dome, and let this is the Rankine cycle. Okay, so somewhat like this Rankine cycle looks like 1 2 3 4 process. Okay, so what do you mean by regeneration? Okay, so regeneration means what we are doing, we are adding some amount of heat here, so that we need to get some work during turbine, that is in the expansion process. Okay, so during regeneration, some amount of heat which is being lost during expansion process, by using that will be reduced whatever amount of heat is being added during our heat addition process. So heat addition process is taking place now from 4 to 1, but if will we add some heat by using this lost heat, then that is that will be known as your regeneration process. So that is actually done inside any Rankine cycle. So if we'll be doing this 4 to, okay, let me change the color here. Okay, so agar from 4 to this point, okay, so if this much amount of heat will be taking from this part, matlab exhaust area, last part. Okay, so next time if we'll be adding heat, then only this amount of heat we have to add. Okay, so whatever amount of heat was required before to add this amount we can say, then that is our matlab, we can reduce that. Okay, so now heat is added from what, now it is added from this part only. Okay, so heat addition process is this part only. Okay, so let it be 5 point, so 5 to 1 only, so we have reduced from 4 to 5 heat addition process. Okay, so due to that, matlab, what will happen here, so the average temperature of heat addition will increase. Okay, so average temperature of your heat addition will increase, so that our efficiency will be increased. So let us check which option is correct here. Okay, so you can first point, pressure inside the boiler increases, so that is not correct one. Heat is added before steam enters the lower pressure turbine, so that is not the reason actually. Average temperature of heat addition of the boiler increases, so option C is the correct one. And total work delivered by the turbine increases, no, that will be also not correct, because if we'll be viewing turbine, so total work remains same, so there will be no change in total work, because we're not changing some anything in this process. Only what we are doing, we will be taking some amount of heat from here and providing here. Is it correct? Is it clear to everybody? So moving next. So a process in which working substance neither receives nor gives out heat to the surrounding during expansion process or contraction process. Okay, so basically if there will be no heat interaction, that is known as your adiabatic process. So no isothermal, no isentropic, so this is the adiabatic process. So option D is correct here. Then if okay, wait for a while. Okay, so if del q is the heat transfer to the system, and del q is the what work done by the system, then which of the following is the exact differential? Okay, so you know the first, from the first law of physics, del q is equal to de, or du you can write. Okay, de plus what, that is del w. Okay, so in which del q and del w, these are the inexact functions. Okay, so de, that is the internal energy or total energy, that is the only what we can say it is an exact differential. Okay, so if I can find de here, so de will be equal to what, so del will be equal to del q minus del w. Okay, so this will be the exact differential, so here option D is correct. Okay, moving next. Okay, the ratio of specific heat of a gas at a constant pressure and constant volume. Okay, so it's telling about to Cp and Cv. Okay, so Cp by Cv, that equal to gamma. Okay, so it is gamma. So Cp by Cv, what happens? Okay, what happens to Cp by Cv? There is with temperature, no. So Cp by Cv, that is gamma, remains constant for a gas. Okay, for a gas Cp by Cv will be remaining constant, so we can write which will be correct one. uh, So here it doesn't varies with temperature, it doesn't vary with pressure also, it always remains constant. So for 30 it will be C is the right option here. Then next, okay, the piston of an oil engine of area, so it is in meter square, not meter cube. So okay, so 0.0045 meter square area moves downward, okay, downward 75 mm. So area is given this value, that is 0.40045 meter square, and your L is given, that is the stroke length 75 mm. Okay, so we can convert this into meter, so that will be equal to what, 0.0075 meter. Okay, then okay, drawing 0.00828 meter cube of fresh air from the atmosphere. The pressure in the cylinder during okay, uniform cooling, uniform pressure is uniform, so pressure is given, that is 80 kilopascal. Okay, then while the atmospheric pressure is given, that is 101.325, and the displacement work, so we need to find out the displacement to work here. So we know displacement to work, that is W will be equal to generally P dV. Okay, so pressure, that is a constant pressure inside the cylinder, and dV, that is change in volume. Okay, so what is the change in volume, that is the what during the piston movement, what is the okay, what is the piston movement, we can say. Okay, what amount what volume is your piston moving, that is known as change in volume, you can say. So in case of your engine, or in case of your what that is cylinder, when piston is moving, what will be the change in volume, or what is the piston movement, so that will be equal to Vs. Okay, so if you can say this is the volume matlab piston movement diagram. So if we are drawing like this, okay, so piston was somewhat here first, and it is moving to this one. So total volume, so Vt, okay, so this is the Vt, that is total volume. Okay, and piston moves from here to here, so that is your sweat volume. Okay, and this is your clearance volume. Okay, Vc, and Vt will be equal to Vc plus Vs. Okay, so here the movement of your piston is taking place during your sweat volume only. So if you can find out the sweat volume, that is piston movement volume, okay, so we can calculate the what work done. So W equal to what I said, that is P into dV, or dV equal to what, Vs. Okay, so P is given, that is 80 into 10 to the power 3, 80 kilopascal it was given. Okay, and dV, Vs, so Vs we can calculate the circumference area. Okay, circumference area of the piston, that is given 0.0045 into your length, stroke length is given 0.075. okay, so if we'll be multiplying this three term here, then we can calculate that it will be 27 joule. Okay, so do calculate this and find out the answer here. Then moving to next, saturated liquid at a higher pressure P1. So at the saturation liquid okay, at the pressure P1, HF1 is 1000 kilojoule per kg. Okay, HF1 means enthalpy at the saturated liquid region. Okay, and it is throttled to a pressure P2, throttled to P2 pressure, and the enthalpy at saturated liquid and saturated vapor is given. So we can find out what it is asking to find out the dryness fraction of the vapor after throttling. Okay, so let me draw the diagram how it can be look like. Okay, so if it is T, it will be the S, and it will be vapor dome. Then if this is the P1 region, and this is the P2 region, okay, so it will be somewhat like this, it will be somewhat like this, superheated region. Okay, so first your liquid or first point was your P1, okay, pressure P1, okay, at the saturated liquid region. Here this is the what saturated liquid region, okay. So this is the saturated liquid region. From here, at a constant enthalpy, we can say, okay, throttling process, as we know, this is a constant enthalpy process, okay. So it is being throttled to a pressure P2, okay. So from here, let this is point 1, this is point 2. So from here, that is from point 1, it is throttled to point 2, which is at pressure P2, okay. So this point enthalpy is known to us, and what are the other given data? The enthalpy at saturated liquid at the and the saturated vapor, okay. So at the pressure P2, this is our saturated liquid region, okay, and as a pressure P2, this is our saturated vapor region, okay. So we know the enthalpies at this point and this point also, and we need to calculate the dryness fraction at this point, okay. So how can we calculate? So we know the enthalpy at point 1 will be equal to enthalpy at point 2, because it is an isenthalpic process, okay. So if we know at enthalpy at point 2, so H2 will be equal to, from this this two what 2 points also, 2 enthalpies also. So H2 we can find out, that is HF2 plus X, that is dryness fraction at 2, so X2 into Hg2 minus HF2, okay. So everything is given to us. H2 is given, H2 will be equal to H1, okay. So H1 is given 1000, HF2 that is given 800 kilojoule per kg, and Hg2 that is given 2800 kilojoule per kg. So you can calculate directly here. So let me calculate this one, okay. So if next we have to calculate what X, that is X2. So that I can write what H2 minus HF2 divided by Hg minus H, that is Hg2 and HF2, okay. So H2 it is given this one 1000, okay, and HF2 it is given this one 800 divided by, okay, Hg2 that is given 2800 minus HF that is 800, okay. So here again 1000 minus 800, that is 200 divided by 2000. So we will deduct, we can calculate 1 by 10. So that will be equal to what 0. Okay, 0.1, okay. So 0.1 will be the answer here. So here option number A will be the correct one. Next, for which of the following situations zeroth law of thermodynamics will not valid, okay. So according to zeroth law of thermodynamics, it is telling about the thermal equilibrium condition. Means if we'll be adding some amount of adding two mixtures or two substances, okay, then there will be thermal equilibrium, means temperature will not change actually, okay. So let me check which option is not obeying the that is thermal equilibrium condition, or that is a zero law of thermodynamics, okay. So 50 cc of water at 25 degrees centigrade, it is mixed with 150 cc of water at 25 degrees centigrade. So it is obeying that law, okay. So there will be no change whatever amount will be added, okay. So that doesn't change the temperature. So next moving to okay, so it is obeying. Then 500 cc of milk at 15 degrees centigrade, again mixed with 100 cc of water at 15 degrees centigrade. So it will again doesn't change any temperature. Then moving to next, 5 kg of wet stream at 100 degrees centigrade is mixed with the 50 kg of dry and saturated steam at 100 degrees centigrade. So it will also don't change any temperature of that system, okay. So next D option is 10 cc of water at 20 degrees centigrade are mixed with 10 cc of sulfuric acid. So at the same temperature, what we are doing in the fourth option, 20 degrees centigrade, that is water that is H2O is mixed with sulfuric acid, that is H2SO4. Okay, so if we'll be adding water with sulfuric acid, there will be chemical reaction. Due to that chemical reaction, your temperature will increase. Okay, but it is telling that it should obey the what, zeroth law of thermodynamics, but it will not obey the zeroth law of thermodynamics. The option D will be the correct one here. So for 33, option D will be the correct one. Okay, moving next. The compression ratio of a gas power plant corresponding to maximum work output for the given temperature limits the T minimum and T maximum. What will be the relation? Okay, so you have to remember, if you have gone through the gas power plant cycle, so you know for maximum work output, T max by T minimum whole into gamma by 2 into gamma plus 1. So option A will be the correct one. Okay, keep remembering it, and if you can derive, then it will be okay also. So this will be the correct one. Then moving next, the Carnot cycle consists of two reversible adiabatic process. Okay, and what? Okay, so obviously we know Carnot cycle consists of two reversible adiabatic process and two reversible isothermal process. So option A will be the correct one. Okay, so here option A will be the correct. Then equivolume of 36, equal volume of all gases at the same temperature and pressure contain equal number of molecules. This is the Avogadro's law. Okay, so if we'll be asking about your Charles law, Gay-Lussac law, in case of your Charles law, your pressure remains constant, and there will be relation between volume and temperature. But in case of your Gay-Lussac law, your volume remains constant, and there will be relation between volume and temperature. In case of your Boyle's law, your temperature remains constant, and there will be a relation in between pressure and temperature, pressure and volume. Okay, so these are the different gas laws, that is, and Avogadro's law, it's dealing about the number of molecules. Okay, then moving next. Okay, so it is being repeated here, already we have discussed about it. Sorry, 37. So in the polytropic process equation, PV to the power n equal to constant. If n equal to 1, okay, so we can get PV equal to constant. So PV equal to constant, it is for your isothermal process. So constant thermal process, constant temperature process. Okay, so 37, that is will be C. Then okay, for a reversed Carnot cycle, which figure represents the variation of TL for different values of COP at a constant value of TH. Okay, so what will be the change? Okay, so what will be the value of TL, that is lower temperature, you can say. So we know for a reverse Carnot cycle, that is it will be acting as a refrigeration cycle. So we know that COP will be called what? TL divided by TH minus TL. Okay, so if we will be increasing TL, that is lower temperature, so suppose T del T amount of that is change in temperature. Okay, so we'll be adding del T in the upper side, and we'll be adding del T here also. So what we can see here, if we'll be adding del T, if we are increasing the lower temperature, then we can see this upper part is increasing, and as well as if we will be adding del T to this, then this lower part is decreasing, you can say. Okay, so TH minus this one, if we'll be increasing this one, then this term will increase, so that this total term will decrease. So if this part is increasing and this part is decreasing, then the whole total part will increase. Okay, so if the whole total part will increase, then obviously we can say COP will increase. Okay, so this much we know, that if we will be increasing the lower temperature, then your COP of the Carnot cycle will increase. Okay, so and another thing, it is not increasing linearly. Okay, because this part is also increasing and this part is also decreasing, so we cannot say how much it is increasing actually. So it is not increasing linearly, but it's increasing. So non-linear graph we can get, and non-linear graph, it is given B option. So this can be there, this can be there, and this cannot be there also. Okay, so it is also increasing, but it will be in this direction. Okay, so B option will be the correct one. Then okay, so next question, 39. So in a steam power plant, the heat supplied, so Q is given by 3608 kilojoule per kg, and the enthalpies and entry and the exit is given. So at the entry it is given 2732 kilojoule per kg, and at exit it is given 335 kilojoule per kg respectively. And the efficiency of the power plant is also given. The eta is given that is 0.64 percentage. Okay, and the efficiency of turbine we need to find out. Okay, so efficiency of turbine, sorry, efficiency of the cycle, that will be equal to what? Efficiency of turbine into W divided by Q. Okay, so normally if efficiency is not given, efficiency of turbine will be not given, then efficiency of the power plant will be equal to W by Q. Okay, where W will be equal to what? H1 minus H2. Okay, so and Q. Okay, so here efficiency comes into account, so efficiency will be multiplied here, efficiency of turbine. So we need to calculate the efficiency of turbine here, and everything is given to us, so we can write directly efficiency of turbine, that will be equal to what? Efficiency of that is a power plant cycle, that is 0.64 into, okay, and Q is equal 3608 divided by H1 minus H2, that is 2732 minus 335. Okay, so if we will be calculating this value, we can get the answer. So answer will be 0. Okay, 0.96. So 0.96 will be the answer for this question. Okay, so moving this is the last question. So Van der Waals equation of the state of gas. Okay, so we know that is P plus A by B square whole into V minus B. Okay, so C will be the correct option here. Okay, so thank you for watching this. So already we have discussed 40 questions from your thermodynamics. So previously we have added 20 questions, and today we discussed another 20 questions. So if you have not watched the previous one, go and find from the playlist, we can get that 20 questions also. So thank you for watching this.